Now, okay, gentlemen, what we have here is we have a cheat sheet for enlargement, reduction, inscription, and areas. And what we have in the first row across here is we're going to enlarge a figure from a point. Here we're going to enlarge a figure based on the figure itself, and here we're going to enlarge a figure to a certain size. In the next row we have a reduction. Here we're going to reduce the size of this by a certain scale. Here we have an inscription where we're going to try and fit in the biggest square we can inside the triangle. Here we have an areas where we're going to try and create a triangle with a side length of a particular size to be equal in area. Here we're going to convert a triangle to a rectangle of same area. Here we're going to draw a triangle equal in area to the quadrilateral ABC. Here we're going to draw a square equal in area to the quadrilateral ABC, and here we're going to draw a square equal in area to an irregular pentagon or a polygon ABCDE. Okay, so there's 10 little drawings, and I don't want to delay. I'm going to get to it, so I'm just going to move this over a little bit so we can have a closer look at the first one. Okay, now you'll probably see very lightly I have the solutions kind of pre-drawn, so I need to make sure everything gets fit on the page. So in this one it says enlarge figure ABCD from point O by a scale factor of 2. So we want to enlarge the object from point O, but we want it to be twice the size again we have it done. Okay, so how do we do that? Well, what we do is we measure the distance from A, or 0, which is here point 0, to the closest point there, which is point A. Alright, that's 50 mil. And what we do is because it's a factor of 2, we double that distance. So what I do is I add 50 to it. Okay, and I mark out here, so that'll be 100. And I'm going to call that A1, because that is now A in its new position. Now what good is that to me? Well, when I actually go to enlarge this figure, that point is going to be the starting point for me to create a construction line. So I'm going to, from A1, draw a construction line up there like so. Don't worry about the length of it. Now what I'm going to do is from point 0, okay, I'm going to line up with point D, because point D is going to be directly above A1, isn't it? So this will be point D1 is going to be somewhere up here, by virtue of the fact that we are enlarging from point O. So I extend from O out through D on to hit the line, and I'll put a little arrow in there. Okay, now that's my point D1. D1. Now I want to find point B, okay, in its new position. So in order to do that, what we do is we can measure our initial object. We go, right, that's 20 mil. So if it were scaling up by a factor of 2, that will be now going 40 mil. Okay, so I mark 40 and I go B1. Okay, from B1 again, now I am going to draw a construction line up. Then I'm going to go to point O and line it up with C. Okay, and I extend out to hit the line B1 like so, and that gives me point C1. So there, now what I have, and I can heavy it in now, is I can heavy in the line from B1 to C1, A1 to B1, A1 to D1, and D1 to C1. Okay, that is my figure enlarged and into its new size, and I'll just give it a very light colour there, just so we can kind of distinguish that from the general. Okay, now that's the first one. Lovely, no problem. Next one, rectangle. Okay, draw a rectangle having lengths twice the size of the original. Now you might go, well sure, I'll just measure that there and, you know, maybe redraw it somewhere else. But what I want to show you is how quickly to do that without really measuring too much. So we know that the length AB is 40, so if we're going twice the size, we're going to mark out 80. Okay, from point A, obviously to double the length. So we call that B1. That okay? Now what we're going to do from B1 is we're going to draw a light construction line straight up like so. Don't worry about the length of it. From point A because we're enlarging it from point A, we're going to line it up with point C and project on out. Again, I'll put in my little arrow there, and I'll put in the arrow here on this one. Sorry, apologies about that. And what I'm going to do now is, from that point there, my little T-square is getting locked up there. I'm going to take that point now back across. Don't worry about the length of it. And then from the line AD, we're going to extend that up. So, essentially what we have now, we have C1 and we have D1. Okay? And I can heavy those, like so. And this will be my rectangle with each side twice the length of the original, and I only had to measure once. Okay? I didn't have to go remeasuring everything or anything like that. So this is kind of a short way of doing it, if you know what I mean. Alright? And again, a little bit of colour, just for presentation purposes, just so you can distinguish one shape from the other. Now, moving it on, we're not delaying. The next one here, there's a little more work involved in this one. The figure below is based on a square and an equilateral triangle. Draw it out. So, what you're given here, okay, and this is just, imagine this is just a little kind of a question, not to any scale at all, but we're given the object. It's an equilateral triangle and a square, and we're told that the top to the bottom is 80 millimeters. That's the only measurement we're given, okay, nothing else. And this is quite typical in the higher level rotations question. You'll be given an object and sometimes you have to enlarge it. Alright, and you're only given one measurement in the first place. So we're going to take this example. What I'm going to do here is just on my XY line here, I'm going to draw up a line very lightly. That can be anywhere. This is just a question, that's all. So I'm going to draw a line up 80 millimeters long, okay? And I'll draw it as a center line. So 80 millimeters. Remember, center line is a long dash, short dash line. Okay? Now, there's the 80 there. Lovely. And I'm going to call that point A. So imagine this point A, that's point A there. And remember, that line's 80 millimeters long. What I'm going to do is I'm going to draw a miniature version of this up here now, from point A. So long as it's an equilateral triangle and a square. Yeah? And that's the key thing here, that we recognize in the question itself. It gave you some very, very definite information. So I know an equilateral triangle has a side angle of 60 degrees. Okay, and what I'll do there is I'm going to create an equilateral triangle. So, and I'll give it a side length of, look, 15 millimeters or so. Okay, you can decide whatever there, guys. It's up to yourself. And I'll draw that one on down there like that. Apologies there now. Now, and I just measure the length there, just for my own sake. Yeah, 15 mil, and we can draw it across there like that. And of course then as well, we can draw the square bit, because if the square is matching up with the pentagon, it's going to be 15 mil, the equilateral triangle, it's going to have a side length of 15 millimeters as well. Now, so I have that there, lovely. What I want to do now is I want to enlarge this down to the XY line. That's actually going to give me the real width. Okay, and we're going to get points E and D here on the XY line. So, just for a moment, take a different colour. We might take a bit of pink. From point A, I'm going to line it up with the bottom points here. So, we'll just label the points as here. B, C, E, and D. So I'll line up A with point E, okay, draw through, on to hit the XY line. Now that is the actual point E. Go to A here and draw it on through point D. That is the actual point D. Now what I want to do is I want to figure out, well, okay, I have the width of the square at the bottom, so let's go ahead and construct that square for real, okay? So what I'm going to do here now is I am going to draw a line up from E. Don't worry about the length of it for the moment, or you can just take the length that you already have, ED there. I'm just drawing construction lines here because I want to show you how to locate B and C a little bit quicker. I line up on the line AB there, Okay, and I am going to extend that line on, like so. And it hits here, that's point B. It intersects the line I brought up. And likewise, the line AC, I'm going to extend that on. And there's point C. Okay? And lo and behold, we now have the object we want. So I can just heavy the lines in here. And heavy that line there. Heavy the line joining B and C. Heavy the outside. Like so. And here, like so. And then we'll have the triangular bit at the top. And there we go. Okay? That is job done on that one. Okay? So I'm going to shade that in there. Very, very lightly. Again, just to show you. I'll touch them up after, just to make sure they're shaded in properly. And there we go. Okay? Now, so that's the enlargement done for that particular scenario that can come up. Now we're going to move across here to our next one. So we're done with the enlargements. We're going to go to a reduction now. So draw a polygon having sides 2/3 the length of those of the polygon A, B, C, D, E. Okay? Or an irregular pentagon if you want to call it that. So 2/3. So what we do, go to your line which is on the ground. In this case, it's the line AB for me. And what we're going to do is we're going to divide that line into 3 equal parts. 3/3. Alright? So I'd mentioned thirds there. If it said 3/4, we divide it into 4. This is thirds, so we're going to divide it into 3. And we'll see how we're going to work a solution from here. So what I do here, just draw a line. I'm going to measure that line first, see if I can divide it evenly. No. Okay, I can't. 57 mil long. When I divide it by 3, it's too awkward. Okay? So what we're going to do is just draw a line there, any angle at all. Okay? And on that line we're going to mark 3 equal parts. This is just dividing a line. So there's good revision in this too. Okay? Like so. So I marked out 3 15s there and I labelled them 1, 2, 3. Now I'm going to join point 3 back to B. Okay? And using my sliding set squares, okay, I'm going to take that line that connects point 3 to B, and I'm going to go to point 2, and slide it on to point 1. Okay, and there we go. Now I have the point 1, 2, and of course 3 falls on point B. What we're interested in is this point 2. So this one right here. Point 2. Why? 2/3. Okay? So what we do in that case, and this is all about sliding set squares really from here on, is we are going to line up with the outside line here connecting B and C. Can you see that? So the line of the outside line of the irregular pentagon, line it up, go over to point 2 and draw a construction line first. Okay, we'll do that in a bit of pink. So I'm going to draw that line. Okay, don't worry about the length of it. Okay, how are we actually going to define the length of that line? Well, from point A, we are going to line up with point C out here. Where it passes through, which is here, we get our new position for C. Okay, that's line there now, BC, has been reduced in length by 2/3, essentially. The angles don't change, okay? Just the lengths. So next one, we're going to take the line DC. We're going to line up with it, slide and set squares, down to point C, okay? And we are going to draw a second line like so, okay? And of course that's parallel to that line. I should have put the symbol in here for this one. That's parallel to that line. Okay, so we're parallel. How do we find the point D on this line? Well, we line A up with D out here on the existing polygon. So we line A and D up like so, and we draw a line. Now, what we have here now is our new point D. I suppose there should be called these C1 and D1 and so on. Okay, and the final one, well, not the final one, but what we do is we line up here with the line ED, and we bring it back to D1, and we go again parallel. So that's parallel to here, and we mark the point where it hits the line here. Okay, that's our point E1. And what we have there now is we actually have our polygon, or our irregular pentagon, reduced in size by a third. Okay, it's 2/3 the size of the original. Okay, so we can see that there, and we'll just lightly shade in there as well. Alright, and again I'll just put some directional arrows in here, but you can see sliding set squares, enlarging the points from point A, no bother. Okay, now next one, inscribe a square of maximum size into the triangle ABC. So we go, well sure, you know, how would you do that? Well, what we do is, a bit like the one up here, we're going to draw a little small square and we're going to enlarge it out. So, a square of any size, alright, let's say I take a square with a side length of 15 millimeters or something like that, and I just line it up inside here. Okay, don't be too picky about it. Alright, I'm going to draw it in blue here. Let's say there's 15 mil. Okay, and then I'll come across the 15 and back down. Okay, like so. So now I have a square there. What I'm going to do from point A, I am going to enlarge out this point of the square. We'll call that point X. Okay, right there, point X. So A, enlarge out through point X and on to hit over here. We'll call that X1. Now once I have X1, pretty much game over from there, lads. So we just go X1 straight across now. Okay, to hit the other side. So that's a horizontal line, a vertical line straight down, and a vertical line straight down from X1 there. And what I have now is I have the square inside there. Okay, inscribed inside. It's the biggest one that will fit inside that particular triangle. Okay, and it's just a little handy tool, and again you'll see this popping up here and there in different types of questions, but that's how you find that. And of course you can measure the lengths just to double check. It turned out at, you know, 36.5 there and 36.5 there. Lovely, so that was perfect. Now we're moving over to areas, right? Question 6 here, areas. The first one, okay, is draw a triangle equal in area having one side 60 millimeters in length. So you're going, well, how do I draw an area? I don't even know the area of this. All I can see is a triangle. We don't need to. Okay? This is what we do. Very, very simply. Is we take a... Apologies now. Just having a little bit of problem with the whole board there. What we do is we take, from the top point, point C, we take a horizontal line. Just draw it. Don't worry about the length of it. Just draw a horizontal line. Now, from either point A or B, take the 60 millimeter, which is the length in the question, put that on your compass. Okay, so I'll stretch it out there to 60 mil or thereabouts. No. Okay, so I have the 60 mil there, and I'm going to put it on point, let's say we'll just look at it from the context of point B. Sorry now, my compass is going off a slight bit. Okay, I might just use the regular one for the next one. So, have 60 mil on the compass, I swing an arc to intersect that horizontal line. Okay, so just call that HL, horizontal line, and then the arc intersects it. Okay, and that arc was radius 60, or 60, okay, because it was given in the particular question. All we do there now, guys, is we join up point B, like so, and then point A, like so. So in effect that's our new point C1, if we want to call it like that. And there we go, we now have a triangle, okay, that is equal in area to the original triangle, but it has one side that's exactly 60 millimeters long. Okay, so that's again another handy little one to know. Now, we're going to move down here a little bit further and have a look at these examples down here. No, number 7. This is our second areas question. It says, draw a rectangle equal in area to the triangle ABC, which is this here. There's certain steps that are involved in doing these now. Alright, so it's fairly prescriptive. What we do here is we draw a line straight down from point C, okay, the top point of the triangle. Okay, no matter what shape the triangle is, just drop the top line down. What we want to do now is we want to bisect the line, okay, to find halfway. Now you could measure it and so on, but bisect the line, okay? Keep the same distance on your compass from the other end. Lovely. Now, what we do is we are going to draw our bisector line. Don't worry about the length of it. Let's draw it on there. And from points A and B, we are going to draw up vertical lines. A, draw a vertical line up to hit the bisector, and from B, do the same thing. Apologies there now, I'll have to move my now, and from B, draw a vertical line up there as well. Okay? So, once we have that, and I'm just adjusting my projector into a position that will work for the part down there. Lovely. Okay, so I drew up the two vertical lines, and that gives me the points now for the actual rectangle to be drawn. So like so, I'll just go over it with pink just to highlight the rectangle itself. And that rectangle now that we have there, that is equal in area. Okay. That is a rectangle that is equal in area to the triangle ABC. Okay. Lovely. That's that one done. So all you have to do, drop a line down, bisect it, bisector, lines up to meet it, create a rectangle. Next one here. Number 8. It says, draw a triangle equal in area to the quadrilateral ABCD. So, what I do in this case, guys, and this is fairly straightforward, alright, is I join D to B, okay, the top point down to the bottom point on this side. Okay, and what I do is slide and set squares. So I have that line there, DB, and I go to point C, and I draw a line down at the same angle. So that line that connected D and B, we take the angle of that line, put it to the outside point here, and draw it down. And then what we do is we connect back from this point now that we've located on the ground. And we're going to join it back to, we'll call it point X. We're going to join it back to point D. And this, what we get when we join it back like that is we get our triangle equal in area to the quadrilateral. Okay? So, and I'll just shade that in there so you can actually see the defined shape, like so. Okay? Now, so there you go, you have a triangle there, ADX, if you want to call it. Next one. Draw a square equal in area to the quadrilateral ABCD. Now, bear in mind what we've done in the previous examples, where we have converted triangles into, or quadrilaterals to triangles and triangles to rectangles. We are now going to do that here, okay? So now we start to combine all the elements here when we want to produce a square. So, I'm going to join from here, from D to B, so I'm repeating exactly what I did in the previous example, D to B. Then I'm going to place my set square behind because I want to redraw that exact angle from point C. Okay, like so. So that's parallel and that's parallel. Alright, now what I do here, where that hits the line, we'll call that point X. Okay, now we're going to join point X back to D. And I'm just going to heavy in that bit there as well. So what we have is a triangle ADX. Now, in order to get to a square, we have to first go to a rectangle now. So we've gone from quadrilateral to triangle, then triangle goes to rectangle, and then rectangle goes to square. So, if you remember now, we have a triangle here, ADX. Remember we had the triangle over here, ABC, and we wanted to find a rectangle. Well, what do we do here? We are going to drop a line straight down, okay? So I'm going to clip in my T-square there. I'll just put it up on the top side, and we'll use a little bit of green to do this bit. So what I'm going to do, point D, draw a line straight down, okay? No problem there. What we're going to do now is, like we did over here, we're going to bisect that line. So I'm going to get my compass, okay, stretch it past where I think halfway is, roughly. Okay, it doesn't have to be perfect. And I'm going to draw my bisectors, okay, or my arcs, and then we'll get to the bisectors in a moment. Lovely. Okay, now what I'm going to do, slide down my T-square, and I'm going to draw a line, the bisector line, like so. Now, once I have that bisector line, I want to then draw a vertical line up from point A, okay, and a vertical line up from point X, okay. That was the one I found there. So I now have the 4 points of the rectangle. Now here's the bit you don't know yet. Going from a rectangle to a square, what we do is we take our compass, we'll put it on point X here, okay. Now it doesn't have to be point X, it could be point A either, the other end of the rectangle, but it is the point on the rectangle, okay. And I'm going to swing an arc down, take the length there of the rectangle and swing it down to hit the ground, okay. And just mark that point. We'll call that point Z. Z, okay. What we're going to do is we're going to find halfway between A and Z. Now you can measure that. You can go, alright, okay, it works out at like 81.5. So best thing to do there in that situation is to bisect the distance between A and Z. Now I know you're going, Jesus, there's some steps involved in this, but don't worry, it's grand. It'll work itself out in a second now. So swing an arc, keep the same distance, go to A. Apologies there. Swing a second arc. Okay, lovely. Now, just want to get that more and shot down the bottom there. Hopefully we can see that a little clearer. So what I've done is bisected the distance now between A and Z, and I'm going to draw my bisector in, of course. Okay, and that's just coincidence that the point, it lands pretty much on top of point B. That's just coincidence, okay? So what I'm going to do now is position the compass on where the bisector line intersects, and I'm going to stretch it out to either A or Z. We'll go A there, and I'm going to swing it around, alright, and it'll land there on point Z, okay? Now, what significance does that have to us? Well, what we do here is we are going to extend up now. So I'm going to use red here, so from point X I'm going to just recolour that line and extend it on to hit that arc. Can you see the arc there? Okay, now we'll call that point P. The line XP, that's the size of your square, okay? So all we need to do is take that length and draw the square. A quick way of doing it is just take your compass there on X, measure up to P. Okay, if you want to bring it down to the ground very quickly, and just swing it down to the ground like so. Okay, I'll take that little thing out of the way there, like so. Now, so that's where it hits the ground there. Okay, we can call that N, and of course we can just heavy across there from X to N. And then what we can do is we can draw it up. Meet the line coming across, and let's say we call that point M. Okay, now we have our square there after all of that. Okay, and you can see there's a lot of arcs and lines there, but again, it's very simple when you break it down piece by piece. When you have the quadrilateral, you have to go from quadrilateral to triangle, triangle to rectangle, and then rectangle to square. And we're going to see that just once more here in pretty much the same way with the last example on the page, okay? So, and thanks for bearing with me on this. Area is number 5, this one, 10 overall. Draw a square equal in area to the irregular pentagon A, B, C, D, E below. So we've got to get this irregular pentagon into a triangle, then we've got to get the triangle to a rectangle and a rectangle to a square. So here's how we do it. First thing, let's join D down to point A, okay, and using our sliding set squares, okay, so let's say we do that. We take the angle of that line, just like we did before for the previous ones, and we, from point E, draw a line at the same angle, like so. Now that gives me a point here on the XY line, we'll call it point X, okay, right there. Now, I just want to autofocus there for a second, just to improve quality. That's okay. Now, we're going to do the same on the other side. We're going to join D down to point B. And we're going to use our sliding set square again here, okay? So, we can use it that way. I'll line up D and B. I'll bring it across the point C, okay? Again, that's parallel to that now. And I'm just going to join the lines now to create the triangle. So from D to X over here, okay, that's one bit of the triangle. And then we'll have this point here, we'll call that X1, okay? And we'll join D to that. Okay, so you can see the triangle we have there now. Okay, so that's DX X1. Okay, I'm not going to shade that too heavy because I have other work to do. Now, so there's the triangle. Now, triangle to rectangle. So what do we do? Well, getting very repetitive now, isn't it? So, we drop the vertical line down from point D, which is the top of the triangle. We bisect it. Get your compass. And we bisect. Keep the same distance. Go to point D and bisect. Lovely. Now, what do? We draw the bisector line, okay? And we draw the bisector line just straight across for the moment. Don't worry about the length of it. We're going to join up point X vertically up and point X1 vertically up. That now defines the size of our rectangle. Now we want to go rectangle square. So back to the compass, put it on X1. Okay. Measure the side length, swing it down. Lovely. We'll call that point Z. Okay. Now we're going to bisect the length, the distance between Z and X. So I get my compass, put it on Z, stretch it past where I think halfway is. Okay. Swing an arc. Keep the same distance on the compass. Go to X, swing a second arc. Okay. Now, what I'm going to do is draw the bisector line. Okay. And that gives me this center point here. We'll just call that O. Okay. Okay. So, put the compass on point O now, which is halfway between Z and X, and swing your semicircle. Like so. Now it's coincidence that I passed through point D there. There's a little bit of an inaccuracy there. Wouldn't worry too much about it. What we're going to do now is get our red marker now, and from point X1 extend a heavy line all the way up to intersect that arc right there. We'll call that point P. Okay? Again, same thing as the previous question. We're going to take the compass, put it on point X1, measure up to P, and swing it down to hit the ground. Okay? Hits the ground over here. That's just the way of transferring the width of the square around. You can just measure it if you want. If you don't like using the compass, just draw that across there. And then what we'll do is we'll extend up and we'll extend across. Okay, from P. And we just label them points N and M. Just to be consistent with the previous example. Okay, so give it a little bit of colour there, just to distinguish what our final outcome is. Okay, and that is it. Alright, now I'm just going to zoom back out there, and we'll have a look at that final sheet there with everything on it. And yeah, so We'll just do a quick recap there. I'll just take a little screenshot. Lovely. Now, and just to recap on that, we have the 3 enlargements, the reduction, the inscription, and then we have the 5 areas done out there as well. And these can be used to solve many problems in short and long questions. Okay, so very useful, and I hope you enjoyed it. So what I'll do is I'm going to stop recording here now, and we'll go back to the classroom and have a chat. Okay.